All right, so like I said, 2.6 and 2.7 I'm going to blend into one note. These are called rational functions and asymptotes. So in 2.6 we're going to learn how to graph functions that have vertical and horizontal asymptotes. And then in 2.7 we add on slant asymptotes. So background on rational functions, they are quotients of polynomial functions, which means you're going to get a polynomial on the top, polynomial on the bottom. It can be a monomial, it can be a binomial, it can be a trinomial, okay? It can have one term or many terms in the top or the bottom, but you're going to see them in both. So it means that it can be expressed as a fraction, and it also means that your denominator cannot equal 0 because of the same domain restrictions we've had. If the bottom then is 0, then what happens? Undefined, so you can't do it, right? So the domain of the rational functions is a set of all real numbers except the x values that make the denominator 0. Same thing that we've been doing before. Quick review on domain. So it's all real numbers with the exceptions of these three. If there's a variable in the denominator, which is going to happen this time, we're going to set that denominator not equal to 0. And then solve, that's a restriction. The second is if there's a variable under a square root. And the third, if there's a variable under the square root in the denominator. 2 and 3 shouldn't happen in this section, of course, but they will continue to happen, so you want to make sure you remember that stuff. So example 1 just says, find the domain of the rational function. So I'm looking at this function and recognizing that there's what going on here? There's a variable in the denominator, which means set the denominator not equal to 0. And I get x cannot equal 4. So the domain is negative infinity to 4, union 4 to positive infinity. So all real numbers except for 4. In a minute, we're going to look at what to do with this before we get to there. But for right now, we're focusing on just the denominator. All right, you do this one. So find the domain of the rational function. So you can choose to either factor that or use the even root property. Either way that you should get x cannot equal negative 6 and positive 6. And the way we write that in interval notation is negative infinity to the smallest one, which would be negative 6. Union the 2, so negative 6 to positive 6. Union the biggest one to positive infinity. So this is how you would write in interval notation all real numbers except negative 6 and positive 6. We good on domain because obviously you're going to need it. Okay, then we get into graphing using transformations. So a while back in 1.6, we talked about how to graph using transformations, and if my parent function was f of x equals 1 over x, then I had a vertical asymptote and a horizontal asymptote, and my original curve went here and here. So now what happens if I add something in the denominator? What's that transformation? It's like it being inside the parentheses. What does that do? Horizontal or vertical? Horizontal. Which direction? Left. So this is left 3 places. So we're saying all of that stuff got shifted left 3 places. My vertical asymptote got shifted left. The horizontal doesn't, or sorry, the vertical got left. Horizontal wouldn't matter. But then my curve goes here and here. So that, using transformations, this is not exact. We will get more specific than this. But that would be just using transformations. 1 over x minus 2 plus 1. The minus 2 in the bottom is doing what? Right 2. And the plus 1 afterwards? Up 1. So I'm going right 2 with my vertical asymptote. I'm going up 1 with my horizontal asymptote. And then my curves are going top right corner, bottom left corner. Okay, again, getting close to without touching those asymptotes. Good so far. All right, so the vertical asymptotes of a rational function exist where your denominator equals 0. So in my standard 1 over x function, I have a vertical asymptote where x equals 0. If x is 0, what happens in this function? It's undefined. You can't do it, thus the vertical asymptote. And then if there's a number in the front, you can never have it to be 0, which is your horizontal asymptote, which we'll get to in a second. Here's just some notation. So you're going to see, like if you refer to your book in a couple of slides, you're going to see this kind of notation. I'm never going to test you on this notation. I just want you to know what it means. So this X arrow, A plus, is meaning as X approaches A, so the arrow is approaches A, and the positive would be from the right. So X and Y, think right and left. This would be X approaching A from the left. This is X approaching infinity, which means as it's going bigger. And this is X approaching negative infinity, which means it's getting smaller. Okay, that's what those arrows mean. So if you look at this graph, it says now this is the function. This would be the parent function of 1 over x squared. Notice that both the curves are in the top now. Instead of it being top right, bottom left, they're both up. Okay? And this is that notation we were just talking about. As x approaches 0 from the left, which means as x is getting closer and closer to x being 0 from the left, f of x, which is my actual curve, is increasing or moving towards positive infinity. This is the same thing as saying as x gets closer to my axis from the left, my y is going to get bigger. Over here, it says as x is approaching 0 from the left, or from the right, sorry, which would be here, the f of x is also getting bigger, which means my y is also getting bigger. This says as x approaches negative infinity, so this is the other way. As it's going towards the smallest number, f of x is getting closer to 0. So as this moves left, it's getting closer and closer to 0. It can never hit 0, though, because there's a horizontal asymptote there. And then this one says as x approaches positive infinity, it's getting closer to 0. So it's also, as you're moving to the right, further and further towards infinity, it's also getting closer to 0. Thank you. All right, so this is how we find the actual vertical and horizontal asymptotes, because they're not always at 0. So the line x equals a, and yes, it has to be an x equals because we're talking about a line, just like your axis of symmetry, it has to be x equals. Okay? This is occurring as f of x is approaching infinity or negative infinity. So as it gets closer and closer to that vertical asymptote, your curve is either going to get bigger or smaller depending on which direction it's moving. A horizontal asymptote is y equals b. So notice vertical is x because it's got to be a vertical line, and horizontal is y because it's got to be a horizontal line. These are lines. Again, if I'm asking you for the asymptotes, which I will, you're going to have to give them to me in equation format. This is what they could look like. So 2 graphs with vertical asymptotes and one with 1 and one with none. So here's an example of what it could look like. You could have 2 vertical asymptotes here. You could have the curves here, here, and here, or you could have the flip of this. And I'm going to teach you how to find all those curves, okay? If it only had 1 vertical asymptote, then it's here. You will also have a horizontal, and your graphs are going to go in those corners. This is what happens, or could happen, if there's none. So you might see a curve get closer without touching a certain point, but there's actually not a split in the graph. So you can get all different kinds of graphs. And again, I'm going to show you how to do this. These are horizontal asymptotes. So the first one has a horizontal asymptote, and this is where it gets tricky. There's actually a horizontal asymptote here, but it's still crossing through it. So you can cross through a horizontal asymptote, but you cannot cross through a vertical one. It is undefined for vertical, okay? Horizontal, you can, and what happens is it affects the outer bounds of these graphs. Here has a horizontal asymptote in which, again, you're getting close to without touching that asymptote. And here, there's none. There's no horizontal asymptote. There's no vertical asymptote in this one either. All right, so here's how we find vertical and horizontal. We start vertical. Vertical asymptotes are found when the denominator is equal to 0. So I'm going to take whatever is my denominator. Normally, for domain, I set it not equal to 0 because I'm finding what it can't be. For the vertical asymptote, you're setting it equal to 0 because you want to know what it would be. And then your vertical asymptote is going to be x equals some sort of number. You can have 1, you can have 2, you could have none, you could have 3, depending on what your denominator is. There's 3 different methods for horizontal asymptote, and it depends on the degree in the numerator and the denominator. So the first thing you're going to do when you get to horizontal asymptotes is identify the degree of the numerator, which is the top, and the degree of the denominator.
I don't think it's the same.
Oh, it's fine. So it doesn't, you actually have numbers, which it's fine. You don't have to write all this out. You just have to know what it means. So the n is the degree of the numerator. If that is less than the degree of the denominator, then you have a horizontal asymptote at y equals 0. If the n is equal to m, then you have a horizontal asymptote at y equals the leading coefficient in the numerator over the leading coefficient in the denominator. God bless you. And if n is greater than m, there's no horizontal asymptotes. So let me see, what was the example that's written on yours? F of x. Thank you. Okay, so this is what yours looks like, which you'll see in a minute we're going to work out. But to get the vertical asymptotes, I set the denominator equal to 0. I'd solve it. I'd get 2 this time. X equals 2 and x equals negative 2. Those would be my vertical asymptotes. Then for my my horizontal asymptotes, I'm going to look at the exponents. What's the exponent on the top? What's the exponent on the bottom? These are the same, yes? So if they are the same, then we're doing the leading coefficient, which is the number on the front of the highest exponent, in the numerator over the number on the front of the highest exponent in the denominator. So 3 is my leading coefficient in my numerator. 1 is the leading coefficient in the denominator. And my horizontal asymptote is y equals 3.
Can there be more than one horizontal asymptote?
No. It's either going to be y equals 0, or it's going to be y equals leading coefficient over leading coefficient, or none. All right, so let's look at these. Find the horizontal and vertical asymptote, if any, of the graph of the rational function. So I'll work through the first one with you, and then I'll let you do the other ones. So vertical asymptote comes from my denominator, right? Set this equal to 0, and I get x equals 6 and negative 6. Those are your vertical asymptotes. Everybody good so far? Horizontal asymptotes, I have to look at the leading or the highest exponent on the top and the bottom. So what's the highest exponent in my numerator? 1. How about my denominator? 2. So if you look back on what we just said, what happens when the leading coefficient, the degree in the top is less than the one in the bottom?
0.
It's 0. So y equals 0 is my horizontal asymptote. I lied. I'll do the first 2 with you, and then I'll let you do the rest for yourself. B. What would be my vertical asymptotes? Huh? Yeah. Oh, yeah, this is the one. I knew I was going to come back on it. This is x equals 2 and negative 2, and your horizontal, they're the same. Leading coefficient is 3 over 1, and then you're going to reduce that to y equals 3. I knew that was somewhere else. All right, now look at C. What happens when I set this denominator equal to 0? Do you have an I? Can you graph an I? No, there is no vertical asymptote. There is no way to get that to be 0. I'd get x squared equals negative 1, x equals plus or minus the square root of negative 1, which is not a real number. No vertical asymptote. And horizontal asymptote? Highest exponent at the top is 1. Highest exponent at the bottom is 2. What's that case? If it's less in the top than it is in the bottom, it's 0. If it's bigger in the top than it is in the bottom, that's when it's none. Questions so far? Okay, so what happens when your function can be reduced and you cancel out your denominator is you get a whole. So the very first thing you're going to do before you go to graph these is see if your function can be simplified and if you can cancel things out, okay? So in this case, in this example that's here, it says f of x equals x squared minus 4 over x minus 2. X squared minus 4 can be factored, yes? X plus 2, x minus 2. Then you've got the same expression in the top and the bottom, which means it gets canceled out. What happens right there, as soon as you cancel out the bottom, is there's a hole in that graph. So there's a hole wherever that restriction would have been, which is at 2. You still simplify it. So I'd still cross it out, and then what's left is f of x, or y equals x plus 2, which is what kind of graph? It's a line. So I go to 2, I plot my point, I use my slope, I draw my line, but wherever x is 2 has to be a hole. So holes come if you can cancel the top and the bottom, getting rid of one of the restrictions on the bottom. Does that make sense? Okay. All right, so this is kind of putting it all together. Strategies for graphing. The first thing this says to do is look for symmetry, okay? You don't have to, I know, look at the face. Like, I don't want to do symmetry. It's okay. It's going to help you because you'll know if both of your curves go up or both go down, right? So it will help you. But if you're not the best at symmetry, then make sure you go to the vertical asymptotes, the horizontal asymptotes, the x-intercepts, the y-intercepts. And then beyond that, you're going to plot in some points. And you're going to see if your curve goes above or below your horizontal asymptote. All right, we're going to work one through all the way from the beginning. Jacob, stay with us. It says graph f of x equals 5x over x minus 2 using the 7-step strategy from the previous slide. So again, I'm not worried about the order on it. Usually, I will go vertical asymptote first. Well, first I'm going to see, can that be simplified? Can anything be canceled out? No, okay? So vertical asymptote would be what? X equals 2. Then I go horizontal asymptote. Degree in the exponent and degree in the denominator have what relationship? Same, which means leading coefficient. Y equals 5 over 1, which means y equals 5. I'm going to start by graphing those. Vertical asymptote, horizontal asymptote. You with me so far? Now, usually they go in opposite corners. Upper right, lower left, upper left, lower right. There are exceptions, but at least I know around about what this will look like. The way I get to the rest of that is my x-intercepts and my y-intercepts. So my x-intercept I get by making y 0. What's going to happen when I multiply by the denominator every single time? It gets 0, which means you could literally just look at the numerator to get your x-intercept. So now I know I'm here. My gut instinct says it's going to be here and it's going to be there. To know for sure, I'm going to plot a point over here. So something bigger than 2, like 3. Y equals 5 times 3 over 3 minus 2, 15 over 1, which is 15. All the way up here, but it confirms my curve. Now I didn't do an x-intercept, or sorry, a y-intercept. Why? It was already there. I already had the 0, 0, okay? But you could have also done that. Y equals 5 times 0 over 0 minus 2, 0 over negative 2, which is still 0. These don't have to be perfect, but you do have to have a point in each range. Whether that's an intercept or a point you plot is up to you, or up to the graph actually. But you have to have one in each corner, to the right and the left of each vertical asymptote. Okay, we're going to do one more, and then I think we're at the stop. This says graph f of x equals 2x squared over x squared minus 25. So what are my vertical asymptotes? Good. This time I've got 2. X equals negative 5 and x equals positive 5. What's my horizontal asymptote? Y equals 2. Same exponent in the top and the bottom, so leading coefficient. So now I've got this, this, this. Now x-intercept. Plug 0 in for y. Again, I only need to worry about my numerator. Plus and minus the square root of 0, which is what? 0, but what's important about that? How many zeros are there? 2, what's that tell you about your graph?
It's gonna bounce.
It's gonna bounce. So it's here and it's gonna bounce. Then again, if there's symmetry, which if you had tested this from the beginning, you'd know there would be. The curves are usually here and here. So what I'm gonna do is check it. I'm gonna plug in a number bigger than the right asymptote and less than the left asymptote. And really all I need to know is it above 2 or is it under 2? This is definitely above. This would be 6 and 6/11. So I know it's all the way up here. And then the same exact thing is going to happen with my -6 because I'm squaring it. So that's when symmetry is going to help you, okay? Knowing that if I plot a point on the right, it flips over on the left is going to help. If you're good at symmetry, it only takes a minute to plug in a -x to find that out, okay? But you also know that every time it's squared, it's going to go away. So if you only have x squared or x to an even power, it's going to go away. Questions so far? So takeaways from today and what you'll see in your homework is domain. You're going to see vertical asymptotes. You're going to see horizontal asymptotes. You're going to see what happens if there's a hole. And then you're going to see graphing altogether. The graphing on your homework is going to be multiple choice. The graphing on your test will not be. So make sure you can go through this process of graphing first, then match it. Don't give yourself a false sense of hope by thinking that you know what it's going to look like from a multiple choice graph. Not going to happen. Okay? You will be graphing these by hand on your test. Everybody good? Yeah? Okay, so on Monday we'll get to slant asymptotes. We'll finish up the section, and then that'll be it. That's covered on your test.